Hello everyone. At last we are talking about how we can graph tangent, our tangent function. So tangent's going to end up being a little bit different. It's kind of funky. Let's first talk about how we would go about finding those tangent values. We previously were looking at using like the x and the y coordinates of our unit circle. So in this case, that doesn't necessarily immediately help us. I want to maybe sketch, let's just sketch like the first quadrant of our unit circle. So let's say that's just like a quarter of my unit circle, and here is some angle that goes through some point x and y. So remember, we were always able to drop down a vertical line and form a right triangle here. Being on the unit circle, our hypotenuse was always equal to 1. One of our legs, the horizontal leg, was equal to x, and the vertical leg was equal to y. So if my angle is always here, with the vertex at the origin, 0, 0, and formed between, again, that terminal side, just review some of our vocab, the terminal side of our angle and the x-axis. Then I know that x represents my adjacent and y represents my opposite. Well, let's think back. Tangent is the ratio of opposite over adjacent. So if we're thinking about our xy coordinates on the unit circle, well, that is always, therefore, going to be y over x. So in order to determine our tangent values of all of these angles in our table and otherwise, we want to use our coordinates in this ratio, y over x, opposite over adjacent. It might also be helpful to notice that, well, if y is equal to sine and x is equal to cosine, well, tangent, therefore, is also equal to sine of theta over cosine of theta. That is also true, and something we'll certainly come back to frequently. So, like before, my advice for you is to pause here and make your own tables, fill them out, and go ahead and plot your points. Okay. All right. Let's check our work. Now we will have seen here some repeating values. Some of them are undefined. Those are the really interesting ones here. So our undefined values are occurring at several intervals here. We're only seeing 0, 1, undefined, and -1. That's kind of the pattern that's repeating here. So if we plot that, maybe I'll put my point for now, 0, 0, and then pi over 4, 1. I guess I should have my scale here. We'll go over 4 for pi, over 4 for another 2 pi, so on and so forth. Okay. So what happens then when I get to pi over 2 and my y value is undefined? Well, we're actually going to think back to last chapter. What happened when we had values that caused the function to become undefined? We called those asymptotes. So all of these undefined points are going to become vertical asymptotes. So we'll have a bunch of them, in fact. So right at pi over 2, we'll have a vertical asymptote. Right at 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Those are all going to be horizontal asymptotes. So remember, when we graph those, they will be made with dotted or dashed lines. And our function is going to approach those points. It's going to get closer and closer to those points. So maybe we'll sketch one of those right now. I know right here at pi over 2, I have a vertical asymptote. We should use a straight edge when we graph that. Okay, so that looks like my vertical asymptote. Now I can also see here I've got one occurring at negative pi over 2. I'm going to plot that one as well. Negative pi over 2 is right over here. Okay, and I also am going to plot my point negative pi over 4, comma, negative 1. So that's going to be right here. Again, if my scale is showing that this point is negative 1. So I've got these 3 points and these 2 vertical asymptotes. So overall, what I'm going to see for my cycle, because again, this is a periodic function, is that as we go up towards the right, my function just keeps going further and further upwards. Then it's going to come kind of downwards, cross through the x-intercept, across the x-axis, and then it's going to start getting closer and closer, going downwards, closer and closer to the other asymptote. Now we've got all of these other asymptotes. I've got one at 3 pi over 2, so one that's right along here. So we'll see that same curved shape in between those 2 asymptotes. I could also graph another one over here. We'll see that same curved shape here, and so on and so forth. So let me skip over to our final plot of tangent. Here is what I graphed earlier. So if we were to sort of zoom out, we'd see more and more of these. It just keeps repeating and repeating like all periodic functions. Now, I also have kind of a zoomed in version of tangent. Mine look more like just barely curved lines, but that's because I'm using a scale of every unit is like a quarter. It's 0.25, whereas this has a very different scale. Notice it's going, our scale of 1, I'm showing all the way up to 8 on this y-axis. So you can see if we zoom in, or excuse me, I guess if we zoom out, we see a much kind of more severe curve there to our tangent line. So our period, it's not 2 pi like it was for cosine and sine. It's actually just going to be pi. For every pi units, I'm completing one cycle. Remember, our first vertical asymptote was here at pi over 2, and then we had one also at negative pi over 2, so the distance between those 2 points, those 2 asymptotes, is actually just pi. That tells us our period. So that's what our tangent graph looks like. Again, if you zoom in and zoom out, it looks a little bit different, but overall you're always going to have all of these vertical asymptotes and this curve kind of going from left to right upwards. That is tangent. Okay, thank you everyone.